Chemistry chapter 24, theory video 7. We are going to look at the ligand exchange in a cobalt complex. Now, aqueous cobalt 2 ions also form complex ions. If there is a CO2 plus that we write, it actually refers to the complex in aqueous form. That is, there would be 6 water ligands attached to this cobalt ion. So this gives a cobalt 2 plus cobalt 2 plus in cobalt sulfate is given its pink color by this complex. Now when you add sodium hydroxide to this solution, just like we saw earlier in copper sulfate, 2 water ligands will be replaced by hydroxide ligands. So that means it will be exchanged. The copper, just like in copper sulfate, in cobalt ligand also, the 6 out of the 6 water ligands, 2 of the water ligands will be replaced to hydroxide ligands, and that converts this pink solution to a blue precipitate. And the same thing that we did in earlier situation, same thing can be done here. We can exchange it for ammonia ligands as well. So what we do is when we add to the pink solution of cobalt and water complex, when we add the ammonia solution, a brown solution would be formed, that is cobalt joining up with 6 ammonia ligands to eliminate the 6 water molecules. The brown cobalt 2 complex ion is going to be oxidized by the oxygen in air to CONH3 3 plus. That is a 3 plus ion. That's a complex ion once again. Now when you add hydrochloric acid drop by drop to the cobalt 2 ions, a blue solution would be produced, which has a tetrahedral complex. The product that is given out has a tetrahedral shape, COCl 4 2-. So this aqueous cobalt 2 ions will usually form tetrahedral complexes with monodentate anionic ligands such as Cl minus, SCN minus, or OH minus. That means it would join up with 4 of these anions. That is something that you must understand. Before we go to the question, let's write down a note on this. Cobalt complexes. Aqueous cobalt 2 compounds in cobalt 2 sulfate has its pink color due to cobalt joining up with 6 water ligands to form the complex CO within brackets H2O 6 2 plus. When sodium hydroxide solution is added to this, a blue precipitate of cobalt 2 hydroxide would be formed, which would turn red if warmed when the alkali is in excess. Right? It will turn red if the alkali is in excess. That is, the hydroxide should be in excess. Write down this equation, please. The first one. After that, write down water ligands can also be exchanged for ammonia ligands if concentrated aqueous ammonia is added drop by drop, which would give a brown solution of the complex CONH3 6 2 plus. if left exposed, oxygen in air will oxidize this to cobalt 3 complex. Leave line and write. If concentrated HCl is added drop by drop, tetrahedral complex COCl4 2 minus aqueous would be produced, which is usual for monodentate anionic ligands such as Cl minus, SCN minus and OH minus with cobalt. Please write this equation as well. If you understood everything, please do question number 5. If you did not understand, please raise questions.